Hello, my name is Adam. In this video, we are going to learn how to make the game 2048 in Unity. 2048 is a puzzle game with the objective of sliding numbered tiles on a grid to combine them until reaching the number 2048. It was originally written in JavaScript and CSS over a weekend and released on March 9, 2014 as free and open source software on GitHub. Throughout the tutorial, we'll learn about UI systems, grid logic, and animation. If you need help at any point, feel free to join our Discord community where we can offer direct help. There's a link in the description of the video. If you like the video, consider subscribing to the channel to support my work. It means a lot to me and it helps drive the growth of my channel. Thank you. Enjoy. Let's begin by creating a new project using the Unity Hub. In the top right corner, we can click the new project button. From here, we can choose a template. So I'll be using the 2D template in this case. We can also change which version of Unity we want to use depending on which versions you have installed. So I'll be using 2021.3. Let's name our project 2048 or whatever you want to name it and choose where you would like to save your project. And we can create. And from here, it might take a few minutes, so we'll pick it up as soon as it finishes. Okay, let's import some assets that we will use throughout our project, mainly a font and a tile sprite. In the description of the video, there will be a link to the GitHub project. That link should take you to this here where you can download the entire project and we can use some of the same assets that I'll be using. You can also use your own, of course. Once that is downloaded, I'm going to extract this here. And let's pull out some of the assets that we want to use. So in here, we'll find assets, sprites, and I'm going to drag this one tile into our project. This is just basically a square image, but it has rounded corners. So it just makes things in our game look a little bit better. It's not necessary, but like I said, it just makes it look better. And I'm also going to go in the fonts folder here. And specifically, we just want these true type fonts. So you can sort by type and just grab the TTF files here. The others, the meta files and these asset files will be generated later by Unity. So let's just drag in the TTF files here. And I'm going to create some folders to organize all this. So let's create a folder for fonts and a folder for sprites. Let's drag them in their respective folders. And let's change some import settings. So on our tile, I'm going to change the pixels per unit to 128. This means that for every 128 pixels in our image, it will take up 1 unit in world space. This particular image is actually 512 by 512. So this tile by itself, if you didn't scale it or do anything, it would take up 4 units in our space. But it doesn't really matter because we're going to be doing all UI. Everything's going to be UI basically. So it kind of works a little bit differently anyways. Nonetheless, 128, it's divisible by 512. We don't need to generate a physics shape. We can change the compression to none. It's already a really small image, so it doesn't really need compression. And format RGBA 32-bit. Since it's a 512 by 512 image, we can change the max size to 512. Let's apply those changes and then open the sprite editor for this. We're going to set up 9 tile slicing. So in the sprite editor, let's set the border here to 16 on all sides. You can see these green lines show up and you'll notice that it starts or ends right where the start and end of the rounded corners are. So what this allows us to do is resize this image without the rounded corners being stretched incorrectly. So we can kind of make this as big or small, as wide, as tall as we want, but the rounded corners will always still be the exact same, which is what we want. We don't want them to stretch weird. Let's apply those changes. We can close that. And then finally for our fonts, let's first install TextMesh Pro. It probably already is installed by default, but if you open your package manager and window package manager, you can check which packages are already installed in your project. And you can see TextMesh Pro, in my case, already is installed. If it's not installed for you, you can go to the Unity registry and you can find it in the list here. And then when you select on one, there will be an install button in the bottom right hand corner. So once that is installed, and like I said, it probably already is, we can go to Window, TextMesh Pro, and let's import the TMP essential resources. And we'll just make sure all of these are selected and import. That will create a new folder here with all the assets that TextMesh Pro uses. And now finally, let's select all of these fonts here and let's right click, create TextMesh Pro font asset. This is going to generate a TextMesh Pro font for all of those. And that's it in terms of importing assets and setting them all up. Okay, let's set up our scene in our canvas. So by default, Unity provides us our sample scene here. In the left is our hierarchy that lists all the game objects in that scene. And then if we were to select one, we can see the components on that object and all of its properties. So let's first rename our sample scene. I'll just call it 2048. It doesn't actually matter, but feel free to change that. And then I'm just going to change our camera here. I'm going to switch to the game view here so I can see the background here. I just want to change the color of this. So for me, feel free to set it to whatever you want, but I'm going to use the same colors that are used on the website. So I'm going to use this hex code here, FAF8EF. Once again, feel free to set it to whatever you want, but that's what I'll be using. All the other settings can remain the same. You do need to make sure your position of your camera is at -10. Otherwise, the UI and whatnot will get clipped and you won't see it. And then let's right click in our hierarchy and go to UI canvas. This is going to create our canvas, which is used to render UI elements. And you also notice it created an event system. This is used to handle certain UI events like clicking buttons and things like that. The only thing we really want to change here is our canvas scaler. This is used to scale the UI to different screen sizes. It's especially useful if you're developing for mobile, for example, because on mobile, there's a lot of different screen sizes for different devices. So I'm going to change this to scale with screen size. And we need to provide a reference resolution. So usually you should design your UI around a particular resolution and then let it scale from there accordingly. I typically set this to 1920 by 1080 because I mainly develop PC or desktop applications. And 1920 by 1080 is the most common resolution for desktop monitors. However, for this particular game, from some of my testing, I felt like 1920 by 1080 was a little bit too large. So I'm going to use the same aspect ratio, but I'm going to just make it a little bit smaller. So I'm going to use 1280 by 720. This also works pretty well for like tablet devices too on mobile, but it doesn't necessarily matter. There's no like right or wrong here. It really just depends on what what devices you're planning to build this game for. Once you have all of the UI built, you can just change these settings and kind of test and see how it adapts, how it scales accordingly. You can even change your resolution here to kind of get an idea of what it would look like under different resolutions or different aspect ratios. So the only last thing I want to do here is I'm going to change the match here. So what it's going to do is it's going to see what is the current screen size of whatever device your game is running on. And if it's smaller or bigger, it's going to scale accordingly. But this is used to measure, if it's all the way scaled to the right for the height here, it's just basing it off of the height of the device or just the width of the device. I typically like to go right in the center to do 0.5. But once again, you might need to just play around with this depending on what devices you are targeting. Now let's create our grid for our game board in our canvas. So let's right click on our canvas and let's create an empty object here. I'm just going to call this board for game board. And I'm going to set the size to 500 by 500. That'll give us plenty of space to work with. And I'm going to let it be anchored right in the center of the screen here. Now let's create a background for our board. So let's right click our board and go to UI image. I'm going to call this background. Let's change the color of this so we can see it a little bit better. So once again, feel free to change the color to whatever you want, but I'm going to set this to BBADA0. And this is where we'll start using our tile sprite pretty much for everything. We can just drag that into the source image, and now we get the nice rounded corners. Now this needs to be a lot larger. It needs to scale or stretch to the same size as our entire board. So if we click this diagram here and then go to the bottom right, this will stretch it on all sides. And then these values become offsets. So it's offsetting it 200 pixels on each side, but we don't want that. So we just want to set all these to 0. It's going to stretch it to fit the parent object here, which is 500 by 500. So now if we were to change our parent object, you'll notice that our background stretches and it stretches it accordingly. All right, finally, let's set up our grid of the actual tile, like cells that will be used for the game. So let's right click our board again and create another empty object. And I'm just going to call this grid. I'm also going to have this stretch on all sides. Although I do want to add a little bit of padding on the edges. So I'm going to add some padding to 16 on each side. So this kind of offsets it a little bit from the edge there. Just makes it look a little bit better. And then in our grid, we need rows. So let's create an empty row here. We're going to resize this, but let's add our cells first, and then we're going to use something that will kind of size everything for us. So let's right click our row and then go to, let's name this cell. Oh, you know what? This could have been an image. So let's actually right click. Let's delete that. Right click row and go to image this time. And this will be a cell. And same thing, we can use our tile sprite here. So let's drag that in. Makes it rounded, nice and rounded, which looks good. Okay, so that's one cell. This is supposed to be a 4x4 grid. So let's resize this as well. Or not resize. I was meant to say duplicate. Let's duplicate this cell. So there's 4 of them. And I'm just going to rename all these to cell. And then we need 4 rows. So let's duplicate our row. So there's 4 of them. I'm just going to call all these row. And now we'll do a little trick here to make all of these, to resize all this automatically. Although I forgot to change the color of all our cells. Now I'm going to go back and select all of these. So let me select all of our cells here and change the color. Once again, feel free to set the color to whatever you want. But for me, I'm going to use CDC1B4. Okay, so now let's automatically resize this into a grid. For our rows, select all of our rows and let's add a component called horizontal layout group. So this is going to automatically lay out our cells horizontally. And then for our grid, let's add a component called vertical layout group. This is going to lay out all of the rows vertically. Now for our rows, I do want some spacing in between each cell. So I'm going to set the spacing to be 16. I probably want to set, actually, it doesn't really matter what the alignment is here. So by default, it's going to force expand the width and height. I believe we do want that. I also want it to control the child size, width, and heights. And then same thing for our grid here too. So that stretches everything to fill. And then this also should have 16 spacing. And so now we have a perfect grid. So basically we're letting these components vertical layout group and horizontal layout group, setting the spacing to 16. So there's always 16 spacing between everything. And we're letting it control the size of everything. And we're force expanding it to fill the available space. So this is perfect. Now there's one caveat to all of this, which is that I noticed when, for whatever reason, when you start actually writing the logic for the game and we set the positions of our cells and whatnot, and we animate things, the values were not correct because these values are sort of set automatically, and in code they're just not correct. So now that we have our grid set up, we actually want to remove these layout groups. Otherwise, if you don't remove them, things will start breaking later on once we start animating and doing other things. So let's remove these. It should not alter the grid at all. Maybe let's remove this one. Yeah, let's start with the grid one first and then remove the rows. Okay, perfect. Yeah. It should stay in place. It shouldn't like, it shouldn't. If you notice when I did it the opposite way, if I deleted the rows first, they got messed up. So we don't want that. So let's delete the vertical layout group for the grid first, and then all the horizontal ones for the rows. Everything should stay in place. And this will be important later on once we actually start coding everything. There's one more quick change I want to make to our cells here, which is I don't want them to be as rounded as our background. So I'm going to select all of our cells again. Ideally, I should have, once again, made this change to the very first cell before I duplicated it, but I kind of forgot. I'm just going to select all of our cells here. I'm going to keep the image type at slice, but I'm going to change the pixels per unit multiplier to 3. And this will make it a little bit less rounded, which matches the way the website looks. It's a little bit more subtle, but it works a little bit better in this case. Or at least visually, I think it looks better. And that's it. I just wanted to quickly make that change there. Okay, before we can start scripting, we just got to do one more thing, which is create our tile prefab. A prefab is a prefabricated game object that you've turned into a project asset that you can then reuse over and over and over again. Allows you to make a copy of that object, and it'll inherit all of the same components and properties and everything. So let's right click on our canvas and create a new object here. We're going to create, let's start with an image here. I'm going to rename this to tile. We don't actually care about where it's positioned because this is going to end up getting deleted once we've created the prefab asset. We do want to set the size though to match the same size as our cells. So in my case, the cells are all 105 by 105 in their width and height. So I'm going to also match that 105 here. I'm going to use our tile sprite here as well. Change the pixels per unit multiplier to 3 to match the cells. The color itself doesn't really matter because it's going to change depending on the state of the tile and like what number it is. Is it 2, 4, 8, etc. It'll change the color. We do also though need to add a text object to this. It'll display the number. So let's right click on our tile and let's go to UI and then text Mesh Pro. Assuming you're using Text Mesh Pro, you'll want that one. You can use the legacy text component too, but in my case, I'll be using Text Mesh Pro. I'm just going to rename this to text. And let's change a bunch of settings here. So let's center it and middle align it. Let's just for now, once again, the color also won't really matter because it's going to change dynamically depending on the tile state. But for now, let's just make it a color let's just make it something so we can see it. And I'm just going to set this to a random number. Once again, it doesn't matter. This is going to get set in code, but I just want to be able to see what it looks like here as we set it up. I do want to change the font here. So this is why we created those Text Mesh Pro font assets earlier. I'm going to use the bold one here. And then I just want to make it a little bit larger. But the problem is you might run into cases like once you get into very large numbers, like 2048, for example, the letter 2, that's really small. So that could be a lot bigger, but 2048 needs to be smaller because it's, there's more characters to it. So you can actually do this auto size thing, which is pretty neat. And you can just let it kind of size it for you automatically. So in this case, if I just have the letter 2, it's auto sizing to 36.95 versus if I had more, it's going to scale it down. Now the problem is this isn't quite working the way I would expect, and that is because our text is, you can see its transform here is exceeding our tile itself. So I'm going to change this to stretch on all sides and set all of these to 0. And now you can see it's going to size it depending on, so as I go in there. Now we might want to actually add some padding on the edges, just like we kind of added padding here. So I'm going to actually add some offsets, 16 on each side. That looks a lot better. So now it scales down. Let's say with number 2 will be a lot larger compared to something like 2048. So that works well. Let's see what else. Actually, I do want to adjust these auto size numbers a little bit. I'm going to maybe do 18 and then 92. I think allow this to be... Actually, it doesn't even matter really, did it? No. I guess the defaults are completely fine, to be honest. Okay, I think that is good. The one thing I don't like is it doesn't visually feel centered in the actual center of the tile. It looks like it's down a little bit. So instead of doing this middle alignment, the vertical middle alignment, I'm actually going to change this to be cap line instead. Notice how that looks, just that actually you can see the little pivot point here, this little blue circle. Notice how the actual number 0 is not centered with that, but then I changed it to cap line and now it's perfect. Now this might vary depending on what font you're using. So if you do use a different font, you might need to play around, but just play around with these and see how it looks visually until you like it. And that is good. I think that's it. I'm gonna get rid of the text here. I'm just gonna set the text color back to white as well. Once again, it doesn't really matter. It's gonna get changed, but okay, so that's our tile object. Let's now just turn it into a prefab. All we have to do is drag it into our project panel. So just drag this here, and now we have tile.prefab. And once we have the asset itself, we don't need it in our scene anymore. We can just delete it from our scene. And we just have a copy of it here. And you can still open this up and edit it and do whatever you need to. I do want to create a folder though to put this in. So let's create a folder. What happened there? Create folder, prefabs, and we'll drag that in there. And that's it. And now we can actually start scripting. So for our first script, let's define a data structure for a tile state. So a tile state is basically for every number, there's a different state. The state being what is the color of our tile, like what's the background color of the tile and what's the text color of the tile. Every number has a different kind of set of colors. And we're going to define this all in a tile state. So let's go, well, first let's create a folder for our scripts. And let's right click in here and create C# script. I'm going to call this tile state. Now we're going to do something a little interesting here that I don't think I've actually done in any of my other tutorials before. Instead of inheriting from mono behavior, that's the default that most things inherit from. That allows you to actually add the script to a game object here in your scene. I'm going to change this to instead inherit from scriptable object. The description says a class you can derive from if you want to create objects that don't need to be attached to game objects. So we don't need to attach a state to an actual game object itself. We don't need to drag this onto something in our scene. This is basically just going to store data for us. So let's delete all the boilerplate there. And what our tile state actually is just essentially a data structure that will define what is the background color of our tile and what's the text color of our tile. So let's declare these as public fields here, color, and let's call one background color, and let's create another one for text color. Now, in order to create a scriptable object, you'll create it just like any other project asset. So it's basically a way to create your own scriptable, your own custom asset type in a way. And then you can create, different instances of that scriptable object. And so you'll see in a minute it'll become more clear in a minute. We just got to do one more thing here, which is we need a way to actually create it from Unity's menu, asset menu. So when you go to this create menu, we need a way to be able to actually create it from here. So we'll add an attribute above our class here called create asset menu. So put square brackets, create asset menu, and then in parentheses, we're gonna put menu name equals, and we'll give it a name. So I'll just call this tile state. I know Unity is very particular about this, where you need this name here. So menu name space equals space, and then whatever you want to name it. And now you'll see when we go back to our project panel here, we can right click, create tile state. So it's our own custom asset now. And if we create that, now we can see those properties show up. So I'm going to create a state for each of our numbers. So let's start with the number 2. And I'm also going to create a folder for all of these. So let's create a folder for tiles. I'll just call them tiles, I guess. We'll start with 2. And for this one, I'm going to use the color, this color here. Once again, feel free to set them to your own. Make sure the alpha is at 1. We don't want the alpha to be 0. And the text color will be this. Once again, you don't have to use this, but that's what I'll be using. These are the exact colors I use on the website. So that's 2. I'm going to duplicate this. Let's do 4. I'm just going to duplicate this for all of them. 8. Actually, I'm going to duplicate it once we do 8 because the text color will be the same for all the remaining ones after starting with 8. So let's do 4. 4 here is the color for our background and our text. Actually, the text is the same, but the background is a little bit different. For 8 now, it becomes a little bit more orange for the background color and the text color. And I believe from this point on, this text color is the same for all of them. So I'm going to start duplicating this one. So I have 16, 32, 64, 128, 256. So I realize this is a little bit tedious, but sometimes that's just kind of how things are in game development. But once it's set up, once you really will never have to change it again. So, and finally 2048. Now you can go beyond this. We will script our game in a way where you can make it go on infinitely. And if there's not a tile state available for larger numbers, it'll just use the last one available. But the numbers themselves will be able to go infinitely. But so if you want to set custom colors, custom states for different numbers, you can keep going further if you want to. All right, so let's just go through and quickly set all of the background colors on these. The text color will be the same for all of these. So I'm just going to quickly copy all of the, oops, what am I doing? Oh gosh, screwed that up. Let's try that again. There we go. That is for 32 there, or actually, no, that should have been for 16. That was a mistake. So for 16 is that color. For 32. For 64. Okay, 128. Becomes a little bit more yellow now. 256. 512. Okay, and a couple more. 124. Or 1024. And 2048. Last one. Cool. All right, so now as I scroll through these, we can kind of see the color slowly change for each state. These are the exact colors that are used on the 2048 website. So, but once again, feel free to change them to be whatever you want. Feel free to get creative. Okay, now let's create some scripts that will define and manage the various data throughout our game, mostly dealing with the grid here, the grid of cells and tiles. So let's create a few different scripts and then we can write the code for all of them. Let's start by just creating a script called tile. This will be added to each of the tiles on our board. Let's also create a script for a tile cell. So the cell here, the cells are these individual slots you see. They don't move and we'll be giving them coordinates. A tile is the actual piece the actual tile that's going to be instantiated and that will change and animate around and so on. So the cells are stationary, the tiles are not. Let's also create a tile row. And let's also create a tile grid. And these should be fairly self-explanatory, but we can go ahead and add these scripts to our various objects. So the grid will have the tile grid script. Our 4 rows will have tile row. And our cells will all have the tile cell scripts. I probably should have created a prefab for our cell to make this easier, but that's okay. All right. And then our tile script will add to our tile prefab, which makes sense. Let's open up our tile prefab and drag that onto it. All right, let's start by writing the code for our cell. So cell is one of these individual squares here on our board. They won't move, and we need to give them coordinates so we know where they are positioned on the board. I'm going to delete the boilerplate here that Unity provides. Now, the cell by itself cannot determine its coordinates. The grid has to tell it what the coordinates are. So we're just going to declare a property with a public getter and setter and have the grid later on actually set what the coordinates of each cell are, but the cell will store them. So we'll declare a vector2 int. So this is a vector2. It has an x and y axis, and each of those values are integers. Give this a public getter and setter. Now, also, we should have each cell track which tile is currently on that cell. So we can have a reference to a tile here. I'll just call this tile. And this will also have a public getter and setter. And then just as a couple helper properties, we can have a property that determines if the cell is empty and occupied or occupied. So this will be a Boolean, returns true or false. We'll just say empty. We use a little arrow here, so we can use equal sign and then the right chevron, right caret. This will make a property that will essentially compute a value. In this case, it's computing whether or not the cell is empty, and we know it's empty if the tile is null. If there's not a tile on the cell, then it's empty. And then the exact opposite, which is to determine if it's occupied, is if the tile is not null. So that's good for our cell. Let's move to our row now. So we're going to kind of go up in the hierarchy here. Delete the boilerplate. Now each row simply needs to keep track of all the cells within that row. So let's declare a public array of cells. So we have our tile cell, an array of those. This will have a getter, but a private setter. Only the row needs to assign these cells. We don't need other classes to be able to access the setter here. So we can make that private. And then we'll add an awake function. This is a function that Unity calls automatically when this script is first initialized. Make sure you capitalize the A, otherwise it will not get called for you by Unity. We can assign our cells by saying get components. So there's a lot of different get component functions which are very commonly used for Unity. Get component is going to search the same game object that this script is running on. It's going to search for whatever component you specify. You can also do get components plural, so it'll look for multiple of that type. And then you can also do in children or in parents if you want to look kind of traverse the hierarchy down or up. So in this case, we want to find the cell. All the cells are children of the row. So we want to look for get components plural. We're looking for multiple of them, and then in children. And then the type we specify here is the tile cell. So that's it for our row. It just keeps track of all the cells within the row. Now for our grid, it's going to be somewhat similar. It's going to track all of the rows within the grid. And also, we're going to have it track all of the cells too, because sometimes it's useful to loop through all of the cells in the entire grid. And other times it's useful to just loop through the cells within one row. So we're just going to have it track both the rows and all of the cells. So let's declare some arrays here for the rows. Make this a getter with a private setter. And then same thing for the cells. And then we can assign these in our awake function. So just like we did for our tile row, get components in children, tile row. Make sure it is plural with the S there. And then cells, get components in children, tile cell. And let's also add a couple helper properties to this class to determine the size of the grid. Both the overall size, so 16, for example, in our case, it's a 4x4 grid, but also the width and height, which are also both 4. The point of this is so we don't want to hard code all of the logic of our game to assume our grid is a 4x4. Maybe you want to make your grid 5x5 or larger. You can maybe create different variations of this game with different size grids. And so it's a good idea. It's a good programming practice to write our code in a way where it can adapt and it's not hard coded to assume a 4x4. So to determine the overall size of our grid, it's just however many cells there are. So cells.length. The height of our grid is however many rows there are. If there's 4 rows, 1, 2, 3, 4, they kind of go vertically. So that's a height of 4. And then the width, we can just divide the size by the height. So a 16, for example, divided by 4 would equal 4. So our width is also 4, which obviously makes sense. Okay, now we need to also assign these coordinates for each of the cells. So in our start function, this is another function that Unity calls automatically the very first frame that this script is running, or enabled and then running. Once again, make sure it's capitalized or it won't get called. Let's loop through all of our rows. So for int I equals 0, I is less than rows.length, I++. Then let's loop through all of the cells within that row. Int j equals 0, j is less than rows I dot cells dot length. So we're accessing that row at that index, getting the cells within the row, and then looping over them. And then here we can say rows I dot cells j dot coordinates equals a new vector 2 ints, and then the x-axis is actually the j here, and the I or the y-axis is the I. And maybe if it makes more sense, we could rename these to instead be x, or actually this would be y. So here we're looping over the rows, which go vertically, so that's why it's the y-axis. And this is the, when we loop over the cells, we're going left to right, so it's the x-axis. And now this will just be xy, which is maybe more intuitive. Cool. So that is assigning the coordinates of all of the cells within our grid, and we're good there. Okay, and now lastly, let's write a little bit of code for the tile itself. So for this class, our tile needs to manage what state it's currently in. So that's getting a reference to which of these states, as well as what cell that it's part of, and then what number is assigned to that tile. So let's have a variable for our tile state. We're going to make all of these public with a private getter. It's going to be useful to read this data later on in our logic, but we only want the tile to actually manage setting it. For our cell as well, we store a reference to the cell that our tile is occupying. And then what number is this tile currently? That way we can actually do the math to just double the number to then upgrade it to the next state. Okay. And I think that's really it for now. Obviously, there's going to be a lot more logic throughout this class in particular. And we will add some more logic throughout our grid as well to write some helper functions to get a cell using coordinates and things like that. But for now, this is good. We've sort of established essentially the data of all of our classes for our entire grid here. Okay, now let's create our tile board script so we can actually start spawning our tiles and testing out some of the logic for our game. Let's create a tile board here, and let's add this to our object called board. Let's go ahead and edit this. Now, first we need to get a reference to our grid. So this can just be private. This will just be our grid here. We also need to store a list of all of the tiles that have been created on our board. So to declare a list, we need to import using system.collections.generic, which I believe was already one of the things that is added by default, and I deleted it, but nonetheless, it's okay. Let's declare a list here of tiles. And we also need to get a reference to our tile prefab so we can create a copy of it every time we want to place a new tile on our board. So this will need to be public, and we'll just call this tile prefab. And when we make a public field like this, it will show up in the editor. So once this recompiles, if we go back to our board, now we see that field show up here in the editor, and we can assign its value. So we can find our prefab and drag that in there. Now it's expecting in the code, because we declared this as a tile, it's expecting that whatever game object you drag here has to have that tile script on it. So I can't just drag any random object there because it doesn't have the tile script. So obviously make sure your tile prefab has the tile script on it, and you should be good. All right. From here in our awake function, we can get a reference to our grid by searching in the children here for tile grid. This one's not plural, it's a singular. We're just looking for the one reference to the grid. And then for our list, we can instantiate a new list here. And as a little bit of an optimization, we can specify capacity for our list, which just will kind of pre-allocate memory based on pre-allocate the necessary memory depending on the capacity here. So we know our grid, for example, is 16. Now this is okay to hardcode because this is not a fixed capacity. Our list can still resize itself as it needs to if there were more tiles than 16. This is just allocating basically the initial amount of memory for 16 tiles worth, which we know in our case will always be the most, but in the case that you make your board bigger, it can still go beyond this. So if you know you're going to make yours bigger, might as well just set it to be like, say, if it's 5 by 5, you can do 25 or something. Or honestly, you don't even need this; it's not required by any means. But anyways, in our start function, let's add a in our start function, let's create some new tiles and place them on the board. So normally speaking, the game will start with 2 tiles placed randomly on the board. So first, let's create a function to create a new tile. We'll just call this create tile. And we'll call this twice here in our start function. Later on in the tutorial, we will be moving this logic here to a game manager script, but for now, this is fine just so we can get some initial testing in place. So to create a tile, we need to make a copy of our prefab. So we can say instantiate tile prefab, and we can give it a position and a rotation, or we can give it a parent to transform to parent to. So in our case, we're going to parent it to the grid. So we're going to say grid.transform here. And this instantiate will return the new object that has been instantiated. And since, once again, it's typed as a tile, it will return a reference to the tile script as well. So we can do that. And now from here, we need to actually we need to do a couple things. We need to set the state of the tile initially, and we need to spawn it, like place it at a position on the board. So why don't we start by placing it, actually, why don't we start by setting the state of the tile? So let's go to our tile script and let's add a public function called setState. We're going to pass in the state we want to set. And there's a few things we're going to want to do in this function. First is we want to actually assign this property here. So this dot state equals state. We need to specify this here, otherwise it doesn't know to distinguish this parameter from our class member here. Oh, also when we set a state, we need to specify what the number is too. So this dot state equals state, this dot number equals number. And then every time we set a state, we need to update the background color and text color of our tile, as well as the text itself based on the number. Now, we don't have a reference to our image and our text, so we need to establish those. So let's declare, well, actually, first we need to import using Unity engine.ui. That'll allow us to establish a reference to our image component, which is the background of our tile. And then we also want to import using TM Pro, which will allow us to declare a field for our text component. Now, if you're not using TextMesh Pro, you will simply declare this as text, which is part of the UI, Unity engine.ui. But otherwise, if you're using TextMesh Pro, we can declare this as TextMesh Pro U GUI. I'll just call this text. We can assign these references in our awake function. So background is going to equal get component image. And our text is actually a child of the tile. So we'll say get component in children, TextMesh Pro U GUI. Okay. So now we've established those references, we can actually update the colors. So background color equals state.background color and text.color equals state.text color. And then the text.text is going to be this number converted to a string, and we're good there. Cool, so that is setting the state of a tile. Now, before we can actually test that that works, we need to finish spawning these. Now, when we create the tile, we know we're gonna set the initial state to be the number 2, but we need to know like what is the color state. Or we also just need to know what are all of the states of our tiles. Let's declare a public array here of tile state. I'm just gonna call these tile states. Once again, this is a public field, so this will show up in our editor here. And we can assign all of our states. So I think, was there 12 or 11? Let's assign these 2. And we want to put them in order, starting with the lowest to highest. 16, 248, 1632, 64, 128, 256, 512, 1024, 2048. So we only need 11 in my case. Once again, you can add more if you want. And so we can assume, well, the very first one in our array is going to be the starting state. So here we'll say tile.setState, and we're going to say tile states 0. Oops, tile states 0. So we're accessing the first one in our array, and the number will be set to 2. And I don't really mind hard coding this number to 2, because that's pretty, like, that's basically a given with the way this game works. I mean, maybe you would want to customize that. So, I mean, feel free to change this value, or you can even add a public field so you can change it in the editor. But in my case, I don't think there's really much wrong with hard coding this particular value. Now, we also need to place our tile on the board. I guess we could probably see what happens now. They're just going to pop up in the center here. Yeah, so that looks fine. Now, one thing I'm noticing is the alignment of the text looks a little off. Oh yeah, did I not change this? I thought I did. I'm gonna make a quick change here to our text component. So let me change the color so we can see this. So visually, let's use the number 0. Visually here, this doesn't look centered in the tile. You can actually see this little blue circle's the pivot point, and the actual 0 and that circle definitely aren't aligned. I found for this particular font that instead of doing the middle vertical alignment, we can do cap line, and that looks perfect. You can just see the pivot point in relation to the 0 is perfectly centered. So that might vary depending on what font you're using, but feel free to play around with these different alignments to see what visually looks best for you. So anyway, sorry, that was a bit of a side note. I thought I had changed that earlier, but I guess not. Let's go back and test this again. I guess we already know what the result is. Yeah, it spawns the tile in the middle there, and there's actually 2 of them. They're just stacked on top of each other. So now we need to actually place them on a cell. So we actually need to write a little helper function. We don't need to, but we can write a helper function for our grid that'll make this easy, because this is something we're probably going to do a few times through our code, which is we might want to loop through our grid and find a random empty cell. We never want to spawn a tile on an occupied cell. So we might want to write a little helper function here. This will be public. It's going to return a cell. I'll call this function get random empty cell. So it's going to loop through our array, or it's not going to loop through, but it's going to find an empty cell in our array of cells. So to get a random one here, let's get an index. And we know there's, however many cells in our array. So we can just get a random index using Unity's random class. You can say random.range. So we're going to get a random number between 0 and however many cells there are. Now, the thing is that random index here, maybe that cell is already occupied. So we don't want to just simply say return cells at that index, because that cell might already be occupied. So we need to actually have some additional logic to make sure that that cell is not occupied. So what we should do is write a while loop, and while the cell at this index is occupied, we will advance to the next cell and check that that one's not occupied. So while cells at the index we're currently looking at is occupied, we should move to the next one. We'll just advance to the next cell and see if that one is also occupied. Now, the thing is, when we advance the index here, we might go out of bounds. So if we're at the very last cell in our grid, we want to loop back to the very beginning again. So if our index is greater than or equal to cells.length, we want to loop back to the start. Now there's one more problem here, which is that what if you check every cell on the board and every one of them is occupied? This will create an infinite loop, which will basically crash your application. So what we need to do is check what is the starting index. And if we've gone through and our index eventually wraps back around to that same starting index, well, then we know all of them are occupied and there is no empty cell. So let's write here, starting index will be whatever this first index is that we randomly chose. And if our new index is equal to that starting index, well, that means we've checked every cell on the board and they're all occupied. So we can just return null. Otherwise, it will eventually find an empty index and it will then return the cell at that index. Cool. So that is finding a random empty cell. We can now use that in our board to spawn our tile or place our tile at that cell. So let's actually write one more function on our tile script, which is to spawn the tile at a particular cell. So let's say spawn at this cell. Now, the first thing we want to do is make sure that, well, I guess it shouldn't really matter, but yeah, here, we'll come back to that thought I just had. Here we want to assign the cell that this tile is part of. So this dot cell equals cell. We also want to assign the cell also stores a reference to the tile. So we want to say this dot cell dot tile equals this. And then we can update the transform of our tile to be the same positions as our cell. If I can type. So we're setting the transform of our tile to the transform of that cell, or the position specifically, not the whole transform. Now this shouldn't really be a problem because the spawn function should only ever be called once for each tile. But just in case, there could be a chance that if this cell is already occupied, or if this cell has already been assigned for whatever reason, we want to make sure that we are unassigning that cell's tile. So if this dot cell is not null, then this dot cell dot tile needs to get set to null. All right. So finally here in our board, we set the state, and then we can say spawn at grid.getRandom empty cell. Now we know, like in theory, once again, this could actually return null, in which case we'll run into an error. But because we are creating tiles for the very first time, there's no way this would ever return null. So I'm not going to even worry about writing the code to check that this is not null, because it shouldn't matter. And if for whatever reason it did matter, then you've messed something up along the way, and there's a bigger problem you would need to solve at that point. Finally, the last thing we want to do is actually just add this tile to our list here. So we can say tiles.add that tile. All right, let's verify this. So now we should see them show up on the board randomly. There we got 2 and 2. Let's play it again and see that they're different. Yep, so they're there. So that looks perfect. Awesome. So there we go. Okay, let's work on moving our tiles now. Let's open up our tile board script, and we need to check for user input to know which direction to move the tiles in. So to do this, we're going to add our update function. This is a function called by Unity every single frame the game is running, and that the script is enabled. Make sure it's capitalized or it won't get called. From here, we can check for input by saying if input.get key down. And I'm going to use WASD as well as the arrow keys. So we can say W, for example, or input.get key down, key code.up arrow. And in that case, we'll move up, but we'll come back to what happens inside there. Let's add the others. So else, if the user presses, let's say down, so S or the down arrow. Else if they press A or the left arrow. Oops, left arrow. Else if they press D or the right arrow, then we will move. So from here, we need to actually move all the tiles on our board. So let's create a function called move. Maybe we say move tiles. We'll pass in the direction we want to move them. Oh, and I made a typo here. This should be right arrow. So we'll move them in a direction. Now we need to loop through our entire grid, but the direction we're moving in is really important. If you're moving the tiles left, you need to start on the left and work from left to right. If you're moving them right, you need to start on the right and move them from right to left, and then so on. If you move up, you need to start at the top and move to the bottom. If you start at the bottom, you need to go from bottom to top. So that's really important, and that's going to change the way we iterate through our grid. So bear with me for a second here. Normally speaking, we would loop through our grid let's say x equals 0, x is less than grid.width, x plus plus, right? So this is looping in one direction. And then same for the y-axis, y equals 0, y is less than grid.height, y plus plus. The problem is this won't work in all cases. You need to always start on the side that you're moving from. So if you're moving up, you start at the top and go bottom and so on. So instead of just hard coding this to say it starts at 0, why don't we pass in some parameters to specify what the start is? And then also in some cases, you're going to go forward. In other cases, you're going to go backwards. So we can also pass in a parameter to indicate what the increment is. So this now becomes start x, and then this will become x plus equals increment x. So this will end up being +1 or -1. And then start x will be, you know, either 0 or whatever the last index is. And then same thing for the y. So start y and increment y. If we don't do it this way, we would literally just have to duplicate, basically write 4 separate functions for each direction. And then there'll end up being a lot of duplicated logic, which personally I didn't really like. So this in some ways is more complex, but it saves having to write a lot of duplicated code. Okay, so start x, increment x, start y, increment y. Now also here, we should make this so it's x is greater than or equal to 0 and x is less than the width. So we're checking both sides, both bounds, the min bound and the max bound. Same thing for the y here. Y is less than or equal to, or y is greater than or equal to 0 and y is less than grid y. So it's always making sure it's in bounds on either side. Cool. So now from here, let's say when we're moving up, well, first we pass in the direction vector2.int.up. Our starting x, so when we're moving up, it doesn't matter horizontally on our x-axis. We can just start at 0 and increment positively. So +1 there. Now for the starting y, we want to start at the top because we're moving up. We could start at index 0, but actually we don't need to because that's already at the top. You can't go any further. So we can actually skip that first one and just move to the next one. So the start y, instead of it being 0 for the first row, we can just skip straight to the next one. So it'll be actually an index of 1. And then the increment will be +1. For moving down, we're going to say vector2.int.down. Start x will be 0, positive increment. Our start y, we want to start at the bottom. So this is going to be grid.height, but that puts us out of bounds because 0, 1, 2, 3, our height is 4. So 4 would put us out of bounds. We need to subtract 1. But also, once again, this is, if you're at the bottom, it's already all the way at the bottom. You can't go any more down. So we can go up one more row again. So here we can say -2 actually. And we're iterating in reverse. We're going to say -1 there. For left, we're going to say we're moving left. We're going to start at index 1 because we can skip the first column there. We're incrementing positively. And then for y, we just start at 0 and increment positively. For moving right, we're going to say right. We're going to start at the end. So grid.width -1 puts us on the edge there. But once again, we can just skip that column because you can't move any rights anymore to the right. So we can actually say -2. We're incrementing backwards, so -1. And then the y-axis is just normal. So hopefully I got all those right. We'll quickly find out if we didn't. But so within here, now we need to get the cell at these coordinates, x and y. So let's add a little helper function to our tile grid to get that. We'll say public tile cell get cell at our ints x and y. And normally you can, essentially you could just say return rows y. If I can type rows y dot cells x However, we should verify that these coordinates are within bounds. So let's say if x is greater than or equal to 0 and x is less than the width and x, x is greater than or equal to 0 and x is less than the width, and y is greater than or equal to 0 and y is less than the height. Man, I cannot type right now. Then we will return that. Otherwise, if it's out of bounds, we know we can just return null, because if we don't, we'll get an error, which will be a problem. Okay. So here we can get the cell at those coordinates. So grid get cell at that x and y coordinates. If that cell is occupied, well, then we can move it. If it's not occupied, there's nothing to do. Now let's write a separate function for actually moving a tile. So move tile, we're going to pass in the tile we want to move and the direction we're moving it. So here we'll say move tile, cell.tile. So the tile that's occupying that cell, same direction we're moving in, that was passed in here, and we're good there. So we loop over everything. If it's occupied, we'll move it, and so on. And once again, the order is really important, because otherwise you might move one thing over and then it thinks it can't move anymore when it can. So order is really important. Now that logic for actually moving here, this is really the bulk of, like, this is kind of the main logic for the game. So how do we handle this? Well, first let's store a reference to the new cell that we're going to move to or try to move to. Now by default, this will be null, because you might not end up actually moving. We also need, so from here, we need to get whatever the adjacent cell is. So let's say we're at this top left corner, we're moving to the right. We need to get the one adjacent to it and see if that cell is occupied or not. So we can say tile cell adjacent. And why don't we add another helper function to our grid class? So in our grid, let's add a function here that's going to return a cell, and we'll say get adjacent cell. We're going to pass in the cell we want to get the adjacent one to, and then the direction we want to get the adjacent one of. From here, we're just going to take the coordinates of the cell and update them based on the direction. So vector2 ints coordinates equals cell.coordinates, coordinates.x plus equals direction.x, coordinates.y, direction plus equal direction.y. However, this actually shouldn't be plus equal, because if you're moving down would be -1, but -1 makes the index go up, like index wise it goes up. So this actually needs to be inversed. It should be minus equals. Increasing the index makes you go down, but down is -1. So these direction and indexes are reversed. So we need to invert that. And then from here, we can just return get cell at those coordinates. We could just pass in them individually, but let's add an overload to this get cell function that takes in a set of coordinates. And this will just return get cell at coordinates.x and coordinates.y. It's not really necessary, but it just makes it a little bit cleaner in certain cases. So now we can just say get cell at those coordinates. All right, so here we're going to get the adjacent cell to our tile. So adjacent equals grid dot get adjacent cell to our tile cell in that direction. Now from here, so long as this adjacent cell is not null, we can potentially move to it. So while that adjacent cell is not null, we're going to try to move. If it is null, that means you're out of bounds, basically. So at that point, you would stop. So we're going to try to move to the right. If it's not null, we're going to try to move there, assuming it's not occupied and you can't merge and stuff like that. And then so on. And we'll keep going. Well, that's why it's a while loop, because we're going to try to keep going as far as possible. So while it's not null, first we need to check if it is occupied. So if that cell is occupied, well, then we need to handle merging, which we're going to do later. So we'll do merging. Now, whether you can or can't merge, it doesn't matter. At that point, you can't go any further, so we can just break out of our while loop. Now, assuming it's not occupied, that means you can move to that cell. So we can now assign our new cell to be the adjacent one. And then we want to keep going. Maybe we can move further again. So now we want to update our adjacent to be the next adjacent one. So we want to move to the adjacent one of the current adjacent one. So get adjacent cell to the current adjacent one in that same direction. And it'll keep looping until it either goes out of bounds or it hits basically another tile that's occupied. Finally, once our while loop is done, if this new cell is not null, well, then we can actually move our tile to that cell. So let's add a function to our tile class here. We'll say move to the cell. And the logic for this is going to be identical to spawning, except instead of setting the position, we're going to animate it, but we're going to do that next. So for now, I'm just going to literally copy and paste the code from spawn. And this will eventually get changed to be an animation instead. So here we can say tile.move to this new cell. And let me just double check. Yeah, this logic's all good, right? Yeah, it reassigns the cell and updates the position. Cool. And that's good for now. So let's go ahead and test this. Now, I won't be able to like fully test this because we only have 2 tiles and we don't have ability to merge. Let's say we move left, they move left, up, right. Yeah, so there we go. That all looks good. Let's try again with a different set of, yeah, so it's left, down, right. Yeah, cool. So that's all looks good. Perfect. So now that we have our tiles moving, we can actually animate them, which is going to make it feel so much better. Let's go to our tile class, and instead of setting the position here, we're going to animate this. Now, if you were to import like a tweening package to your project, this would be super easy. You could do it in 1 line of code, really. But let me show you how to create a simple animation using a coroutine. So first, to create a coroutine, we're going to need to import using system.collections, which will allow us now to declare a function with the return type IEnumerator, which is necessary for a coroutine to work. We're just going to call this animate. We're going to pass in a position to animate to. So I'm going to just name that 2. Now for an animation, we need to set up basically a little timer. And for a timer, we need to know how much time has elapsed and then what the duration of it is. So I'm just going to hard code the duration to be 0.1 second. Feel free to change that. You can also make a variable for it that you could potentially then customize in the editor, but I don't really see a ton of benefit to that for this particular game, so I'm just going to hard code it. We also need to know what position we're animating from. So we're going to animate from one position to another. So let's just call this from, and this will just be whatever the current position of our tile is. Now we'll set up our animation loop here. While elapsed is less than the duration, we will animate. We'll continue the loop. Transform that position equals vector3.lerp. So we're interpolating from A to B, from one position to another. So from to 2. And then we need to provide a parameter t here, which is essentially a percentage. So what's the percentage from A to B? And the percentage is just how much time has elapsed divided by the duration. Elapsed divided by duration. Once we've updated it, we can increase how much time has elapsed by delta time. That's how much time has elapsed since the last frame. And then we yield. And this is what a coroutine allows you to do, is it allows you to suspend the execution of this function, in this case until the next frame, and then our animation loop will continue again. Once it finally reaches the duration, let's just set the position to be the final 2 position, because based on how the elapsed time increases, it might not be perfectly at our end goal here. And that's it. So that's all we need for a simple animation. Now, instead of just setting the position here, we'll start a coroutine. We'll call our animate function. We're going to pass in the position we're going to animate to, which is just the cell's position. And that's it. So let's test this now. Yeah, instantly just feels so much better when it's animated like this. So there's one problem, however, when animating this, which is the user is still able to press an input while it's in the middle of an animation, in which case it like starts to jump around really weirdly. So we don't want that. So how can we prevent the user from pressing an input while it's animating? Essentially what we're going to do is set up a system. So we're going to kind of wait for all of the state changes to happen, and then we'll re-enable input. So why don't we add a parameter to our... oh, yeah, I already added this on accident. Let me undo this real quick. So let's add a property to our board here. Or not a property. We're going to add a private field called waiting. Basically, we're waiting for the changes to happen. We're waiting for the animation to finish and whatever else. We're just waiting for the state of the board to update before we allow the user to continue. So if waiting is false, well, then we will allow the user to press an input. So if you're not waiting, then they can press an input and move the tiles. If they are waiting, we won't even check for input, and therefore they can't make another move. Now, really what we need to do is say, well, once we move to a new cell, well, waiting gets set to true, right? However, we need to then set it back to false at some point, once it's finished animating and whatnot. So really what we should do is set up a coroutine so we can wait for all the changes to happen. So let's import using system.collections. And let's add a coroutine here for wait for changes. And so in here, we'll set waiting to true. We'll then yield return new wait for seconds. And we can wait 0.1 second. It's the same duration as our animation. Where's that at? Same duration as our animation here. And then once we're done waiting, once that time has elapsed, we will start waiting back to false. And then there will be more things we're going to do in here. We're going to create a new tile. We're going to also check for game over and potentially other things. So this is basically like you're just waiting for the states of the board to update. And then there's a number of things we're going to want to do afterwards. So instead of just say waiting equals true, we would start our coroutine here and we'll say wait for changes. However, this is still a problem because move tile might get called many times during one input, right? Because you're looping over all the tiles and trying to move all of them. So we don't want to start this coroutine multiple times. So let's actually remove that line of code. What we're going to do is we're going to have our move tile return a Boolean. It's going to return true or false to indicate true, it did move the tile, or false, it actually didn't move it. So in this case, it moves to a new cell, so we return true. Otherwise, we'll return false at the bottom of our function. And now what we can do is check if at any point this returns true, well, we know the state of our board is going to be updated, and then we can call our coroutine after we've finished looping over everything. So why don't we add a Boolean here to say our game state has changed. We'll assume it hasn't. And then we'll assign that to be equal to whether or not move tile return true or false. Now there's a problem with this too, which is, let's say the first tile gets moved, and so this gets set to true. And then the second tile doesn't end up getting moved, so this returns false. So now it looks like your state, the game state hasn't changed when it did change from the first tile. So instead of just setting this to equal, we want to do or equals, which will make it so once this gets set to true, it will stay true even if this returns false again. And so now here, if our game state has changed, now we will start our coroutine and wait for our changes to occur. And that should be a lot better. Let's test this out. So now I shouldn't be able to spam my inputs. I'll have to wait for everything to update before I can press another input. So I'm spamming my keys, but it all still works correctly. It doesn't allow me to make kind of multiple movements within the same update. Cool. So this looks good. So one of the last things we have left to do is merging our tiles. So for this, let's open up our tile board and let's go back down to where we added this to do for merging here. So we're already checking if the adjacent tile is occupied. If it is occupied, there's the potential for it to be able to be merged. We need to determine if it can merge though. You can only merge if the numbers are the exact same. So let's add a function here called can merge, and we'll pass in tile A and tile B. They can merge if A's number is equal to B's number. Now you might be wondering, like, do we really need a function for this? As it currently stands, not really. But we are going to actually end up adding a little bit more logic to this. We're going to end up adding a little bit more logic to this function. So for now, it looks like it's not even really necessary to have this, but we'll add more to it. And even then, like it just makes it so the logic of whether things can merge or not is consistent. So you can reuse this function in multiple places and just know the logic is always going to be the same. So here now, let's check if you can merge the current tile with whatever the adjacent tile is, then we can actually merge them together. So now let's add a function for merging. Merge tile A and tile B. Now, essentially to merge them, we're going to delete one, we're going to destroy one of them, and then the second one will get kind of transformed. Because the first one's going to move to the second one anyway, so we can just destroy the first one. But we actually still want to animate it moving over before we destroy it, so there's a few things we're going to have to do here. We do know, however, that this tile will get destroyed, so we can remove it from our list of tiles. We don't need to track that one anymore because it's going to get destroyed once it animates. And then from here, let's add another function to our tile class called merge. This should say merge. Yeah, you're merging to another cell here. So we have spawn in a cell, move to a cell, and merge to a cell. All of these are very similar for the most part. Spawning just sets the position, move to animates the position, and merging does a little bit more. But for the most part, this should be the same. So if that cell is already occupied, we want to clear it out first. We're going to set this cell to be null. And then from here, we still want to animate it. So here, let me think about this for 1 second. So when we merge, we're gonna end up saying merge A.merge to B cell, right? So A is being merged. Yeah. So A is gonna get merged, and we're gonna animate A moving to this new cell. However, A is going to then end up getting destroyed afterwards. So that's why we're setting our cell to null here. Because it's all going to... I guess we don't necessarily need to, but it's going to get destroyed anyways. But we do pass in the cell we're merging with, so we can then animate it just like we did before. So why don't we copy that code here? So we're merging to this cell, so we're going to animate to this cell. However, once it's then been animated to the cell's position, we can just destroy this tile. So maybe what we can do is in our animate coroutine, we can add another parameter here called merging. And at the very bottom, if it's merging, well, then we can just destroy it afterwards. And so here, when we animate it, we'll say merging is true, but when we're just moving to merging is not true. Cool. All right. Now from here, we also need to update the states and the number. So we remove A, then we basically start the animation to move over, and then after it animates, it will get destroyed. And then we need to update the state of B to be the next state. So we need to get whatever the current state is in our array and then just move to the next one. So why don't we add a little helper function to get the index of a tile state. All this is going to do is loop over all of our tile states. For I equals 0, I is less than tile states, that length, I plus plus. If the state we're checking is equal to that tile state in our array, then we return I, that's the index. Otherwise, if it loops through everything and doesn't find it, we'll return -1. That shouldn't ever happen, but just we have to return something. So turn -1 if it doesn't find it. So here we can say int index equals the index of b dot state. And then we're going to +1. We're going to increment it to move on to the next state. However, we don't want to make sure if you're at the very last state, it could go out of bounds. We don't want that to happen. And this is where we're going to write this in a way where potentially you can continue to merge tiles together infinitely. But if you don't have, you can't create infinite tile states. So it'll just use the last one in the array if there isn't any more. So we're just going to clamp our index to the bounds of our array. So we're going to take that and we're going to clamp it from 0 to tile states dot length and then -1. So this will ensure that our index is always going to stay in bounds with our tile states. If you exceed 2048 and go even further, but you don't have any more states, it will just continue using that very last state as it gets clamped. The number itself will just get multiplied by 2. So b.number times 2. And so this is where like we're not capping this at all. It can just go on infinitely. And now we can update the state here. So we'll say tile states at this new index and the new number. And that's it. Now there is something else we're going to need to do, which I'm going to try to demonstrate if I can. Oh, you know what? One thing we need to do as well that we should have done before is after we have moved. So I'm going to need to do this now because otherwise I won't really be able to test very much. Once we finish waiting for changes, we need to create a new tile here. So all I can do is just say create tile. Although we can only create a tile if there's an available space. So we can just check if the amount of tiles in our list is not equal to the grid size, well, then we know that there's still a spot occupied or a spot that's empty that we can create a new tile at. Even if your entire board is full, it doesn't necessarily mean you've lost yet because you might be able to merge things. So we only create a tile if we can, and then later we'll check for game over afterwards. Okay, so now we're creating a new tile after every move. I should have enough tiles to actually test merging here. So if I go down, these should merge. Okay, they did not merge, so nothing is merging. So that is a problem. Let's check what is going wrong here. Okay, so I'm stupid. I never called our merge function. That's probably the reason why. So if we can merge these, let's actually merge them. Merge tile. We're going to merge that tile with the adjacent tile. And then also at this point, if they're merging, we know there's been a state change to our game, to our board. So we're going to return true here as well. All right, let's try this again. Okay. So if I go down, these should merge 4. Good. Now go down, they go 4 again. Okay, so this is an example that I wanted to showcase. If I go up, these 2s will merge to a 4, but then this 4 and that 4 will merge as well. But that shouldn't happen. You should only be able to merge it once per, I guess, movement. So this is actually just gonna magically turn into an 8, which you're like skipping an entire step, which you're not supposed to be able to do. So if I move up, yeah, see, it becomes an 8 when it should have been 4 and 4. And then the user would have had to press up again to then merge into an 8. So you can't like double merge. So how do we fix that? Well, we can just simply add a Boolean to our tile to indicate if it's locked. So let's add a Boolean here to indicate that this is locked. And we will set locked to true when it gets merged. So when we merge here, the cell that we're merging to, so we're animating to this cell, that cell's tile needs to become locked. So you can no longer merge after this merge has occurred. And then finally, back in our board scripts, we can update this logic here to say the numbers have to be equal and our tile B has to not be locked. I think that's it. It's actually quite simple in that regard. Although we will need to reset their locked state. So that's actually one problem. So I don't know if... Okay, yeah. So here's an example where 2 would merge to 4 and then they should be able to merge again. Or shouldn't be able to merge again, which they don't. But now the problem is I'm not going to be able to merge these together because they're both locked. Because we're not unlocking them. So let's just quickly fix that and then we're all done with merging. So after we wait for the changes, we can just quickly loop through all of the tiles in our list. So for each tile in our tiles list, tile.locked equals false. And this gives me an error because this is private. I'm just going to change this to be not private. And we're good to go. Okay, now let's do one final test and we should be good. Okay, so we have 4. So here's an example again where 2 and 2 merged to 4. And then in theory, it could before it would have then automatically merged to an 8, but it won't now. And I'll have to press down again. And because we're unlocking them, it should allow me. Good. So cool. So at this point, we basically have a working game. We just kind of need to wrap up with kind of doing like score and a game over and things like that. But logically, our game is complete. Okay, why don't we create a game manager so we can handle our game state and then check for game over. So let's create a new script here for our game manager. And I'm going to create an empty object in our scene. Create an empty object here. I'm going to call this game manager. I'm going to reset its transform and throw that script onto it. And let's go ahead and edit the script. So our game manager will just kind of manage the state of our game. I just decided to separate the logic into this class just so our tile board class isn't too big because there's quite a bit of logic in there already. So our game manager will need a reference to the tile board so it can clear it and update it and stuff. And then we're going to do some UI stuff as well, but we'll get to that. Let's add a function for start. So here, when our game manager starts, that's when our game will actually start. So instead of doing this now, we're going to remove the start function from our board script. And instead now we will make our create tile a public function so we can call it from our board. We also need though a function to clear the board of all the existing tiles if there are any. So let's add a function called clear board. And we'll just loop through all of our tiles. For each tile in tiles, we're going to destroy that tile. So yeah, let me check something real quick. When we destroy the tile here, yeah, destroy game object. So one mistake you can make here is you could just say destroy tile, which would just destroy that one script. It wouldn't destroy the entire game object. So that make sure you say tile.gameObject to destroy the entire thing. That's just one quick mistake you can make. And then we can also clear our list. So our list will become empty. And something else we need to do first before we destroy the tiles is we need to loop through all of the cells in our grid. So for each cell in grid.cells, cell.tile equals null. So we want to clear out all the cells to indicate that there's nothing occupying them. So that's clearing the board. So now when our game manager starts, we can call a new game function. And I'll make this public so we can hook it up to a UI button in later on. I will call new game in start. And when a new game starts, the first thing I'm going to do is clear the board. I'm going to then create 2 tiles to begin. And then let's enable the board, which will enable the user inputs. Later on, when you get a game over, we'll disable the board, which will prevent the user from doing any inputs or anything. When a script is enabled, the update will not get called. So cool. That's it for that. While we're here, why don't we add a game over function, which we don't really have a whole lot to do in here yet, but we can disable the board as I just mentioned. And then we'll do some UI stuff once we get to it. Why don't we actually check for a game over though? So in our tile board, we can check for a game over. So what determines if there's a game over? Well, a game over occurs when the entire board is occupied and there's no available merges that can be made. So let's create a function to check for this because there's quite a bit of logic to it. Check for game over. It's going to return a Boolean, true or false. The first check is simple. We can just say if tiles count does not equal the grid size, well then that means there's still some empty cells in our grid that we can create tiles in. So at that point, you definitely have not got a game over. So we can immediately return false. So now at this point, every tile in the grid is, or every cell is occupied with a tile, but it doesn't necessarily mean you've gotten a game over yet. We have to check if you can do any merges. So we're going to loop through every tile and we're going to get every adjacent tile to that one. So we're going to say the tile above it. So up grid.get adjacent cell to this tile cell in the up direction. We're going to do this for each adjacent one. So up and down, left and right. So make sure you update the direction and the name, of course, this has to be different for each one. And from here, if the adjacent tile above it is not null and it can merge, these two things can merge, well, that means you have not gotten a game over yet. If they are able to be merged, then you still have an available move you can make. But same logic now, we're going to check for all 4 of these. So if the adjacent tile down can be merged, then you have not gotten a game over yet. Left and right. So basically we check every adjacent tile to every tile on our grid. And if any one of them can be merged, then you have not gotten a game over. If you end up looping through everything and nothing can be merged, well, now at this point, yes, you've gotten a game over, so we can return true. And so finally here, if check for game over returns true, well, then we need to call game over on our game manager. So why don't we establish a reference to our game manager in our board. I'm just going to create a public function here, game manager. And then here we can call game manager dot game over. Once again, make sure this is public. Both public new game and game over are public. And let's test this out, I suppose. We just need to drag in our reference to our game manager on our board here. Otherwise, you'll get a null reference exception. And let's test this out. I'm just going to spam inputs until I get a game over. Oh, I already immediately got a null reference exception. And that's because I forgot to do the inverse, which was to establish a reference to the board on our game manager. So let's drag those in. All right. I'm just going to spam inputs until I get a game over. It's kind of funny playing this game. You can actually get like a somewhat decent score by just spamming inputs and not even really trying. Just like maybe a flaw of the game itself, but okay, I'm getting close to losing here. I'm not trying to win right now. Okay, there we go. So there's nothing, yeah, if we look at this, I can't make any more moves. Nothing can be merged. We should see that when I check the board that it's disabled. Yep, so it's disabled because our script for this ran. So this got called correctly. So that is working as expected. Okay, now that we have our game over logic, let's create the actual game over UI itself. So on our board here, I'm gonna create a new image. I'm going to call this game over. I'm going to use our tile sprite here. I'm going to have this stretch to all sides, set them to 0. I'm going to change the color of this to be this color here. And I'm also going to change the opacity as well. So let me get the exact opacity they use on the website. So set the opacity to that. It doesn't matter. You can set this to be whatever you want. But basically, we're creating a little kind of faded out thing. So creating this little thing that will sit on top. And then I'm going to add a component to this called canvas group. This allows us to change the alpha of an entire group of objects, which we can use this alpha to animate it, which will be nice. And then as a child of this, I can add some text. So let's go add a text here. I'm going to center this. So I'm going to say game over, not game over. I'm going to change the font to bold. I'm going to copy the color from the website. So we have this color here. I'm going to change the font size to 60. I'm going to make sure that this stretches horizontally all the way. The height of this will also be 60 to match the font size. So that basically gives it a line height of 1. I'm also going to shift it up a little bit because I want to put a little button underneath. So I want to maybe bring this up to 48. Yeah, that looks good. Okay, that's all fine. Let's just call this text. And let's also create a button. So I'm going to right click game over and create a UI button, Text Mesh Pro. And for our button here, I'm going to set the width to 128, the height to 40. I'm going to shift it down a little bit. I'm going to change the color of the image here. I'm also going to change the sprites on it to be our same tile sprites. I'm going to change the pixels per unit multiplier so it's not as rounded. The button component itself can stay the same, but we can add what happens when you click it. So let's add that and let's drag in our game manager. Make sure you don't drag in the game manager script in your project assets. You drag in the game object, and then from here you can select which function you want to call. So we're going to call the new game function. On the text for this button, I'm going to change it to be try again. I'm going to make the text color white. I'm going to change the font size to 18. I'm going to change the font to bold. I'm going to change the vertical alignment on it a little bit there. I want to rename it to text. I think that's good. You know, the UI is very subjective, so feel free to like customize it to your preferences. There's no right or wrongs, honestly. So, okay, so that looks good. And so this is where this canvas group will allow us to fade out that entire thing. And we can even animate that very easily. All right, I think that's good. Is there anything else I want to do here? Oh, I do want to I want to change the pivot point on this to 1 and then set this back to -24 so it goes a little bit lower. And then the same thing for no, our text is fine, I guess. Yeah, actually here, let's do this. To keep it consistent, I'll keep the pivot point at 0.5 and then set this to -48. So both the text is +48 and the button's -48, just to kind of offset them evenly. All right, I think that's it. Now we can just actually animate this game over showing up. So let's go back to our game manager. And in our game over function, we can do a quick little animation using a coroutine again. So let's import using system.collections. Let's add a private enumerator. This is our coroutine. I'm going to call this fades. We're going to fade it in or out. We're going to pass a reference to our canvas group that we want to fade. We're going to fade it to some alpha value. And I also want to give this a delay. Once you actually trigger a game over, if it shows this immediately, it kind of feels weird. So I like to kind of delay it showing up by like a second, which is actually what they do on the website too. And it kind of just feels nice. So here we can start a coroutine. We're going to fade out. Oh, well, so we need to get a reference to our canvas group here. So let's create a public canvas group here and just call this game over. So we're going to fade out our game over UI to an alpha value of 0 or to 1. We want to fade it in, and we're going to delay it by 1 second as well. So for a delay, we can just yield immediately, yield return wait for seconds for however long the delay you pass in. And then from here, we'll animate just like we've done before. We'll set a lapse time as 0. The duration, let's say, is ½ a second. What's the starting value of our alpha? So our from will be whatever the current alpha of that canvas group is. While elapsed is less than the duration, we will interpolate the alpha. So mathf.lerp. Mathf.lerp from to t is a percentage. So this is elapsed divided by duration. Then we can increase our elapsed time. I'm going fast here because it's basically the exact same code as the other animation code we did in our tile script. It's the same thing, just in this time, instead of changing the position and using vector3, we're changing a float value. So we're using mathf, but otherwise logically it's the same. And then finally, we'll set the alpha to be the final result once the loop is finished. And that's it. So let's test this. Well, and also now when you do a new game, we want to fade that out. Although when we do a new game, I actually found that just instantly getting rid of it looks a little bit better. So I'm going to say game over that alpha equals 0. And I'm also going to make sure that that canvas is not interactable, because otherwise it might prevent you from clicking on things. Whereas, yeah, same thing here. So when you do get a game over, we do want to make that canvas group interactable. Okay, let's test this out. So we should see this instantly disappear when we start the game because of that code we just added. Okay, nope, I forgot to assign the references. So we need to assign this, drag that in, and now we're good. Let's try this again. There we go. So yeah, it instantly disappears. Let me try to quickly get a game over again. Just gonna go up and down as much as, yeah, actually that's a quicker way. I feel like that's a quicker way to get a game over. Okay, there's a game over. Oh no, I still can move right. Okay, yeah, not quite yet. All right, come on. Maybe this is not the strategy to move up and down. Okay, there we go, right? Nope, not yet. Okay, almost there. Come on. Okay, there we go. So notice how it took kind of a second to fade in, and that looks great. Took a second to fade in, And then it animates in, and I should be able to click this button, and yep, perfect, it resets. Awesome. All right, the last thing we can do is scoring. And so we'll do the scoring and the UI for it. Why don't we start with the UI so we can kind of get that out of the way. So let's see here. On our canvas, I'm going to create not in the board, but kind of it's going to sit above our board. In fact, I'm actually going to move our board down now a little bit so we can add some space to put some score above it. I'm going to move that down -60. And also I want to add a new game button as well. So you can just click the button to just instantly start a new game if you don't want to get a game over. So let's maybe do that first. Let's do a button here. You know what? I'm going to duplicate the button from our try again because stylistically it's basically going to be the same. I'm going to move this out into its own thing. Oops. I'm going to call this new game. I'm going to just change the text on it to be new game. And then I'm going to change the function that gets called. Oh no, the function is the same. It's still new game. And then position wise, I'm going to move it up above. So our let's see here. What am I trying to do right now? Our board is 500 by 500. So half of that is 250. But then we just offset it by 60. Yeah, so that puts our pivot points at the middle, so that puts it right there. I'm gonna actually change the pivot point to be 1 and now, or 0. I want it to be 0. So now if I do 250 minus the 60 offset that we shifted our board down, puts it right at the edge there. And then I know left, if I change the pivot X to 0 and I do -250, it'll line it all the way to the left there, which is perfect. And then from here, I might want to just offset it up a little bit, maybe 40 units, or maybe, you know, maybe 24. Yeah, I think that looks pretty good. So that'll be our new game button. You can decide maybe if you want it on the right or the left or however you want to set it up. But for me, that's good. Let's just quickly check that that works. There shouldn't really be much to it. I should be able to just now click new game. Yeah, and it starts over. Okay, so that's pretty simple. Don't even have to change any code for it. Now for our scoring, let's add, I'm going to add a new UI image here. I'm going to add our tile sprite to this. I'm going to set the color to be this color here. I'm going to size this to 112 by 56. I'm going to also change the pixels per unit multiplier to 2 to make it a little bit less rounded. I'm going to set the pivot to 1. I'm going to right align it this time. So this will become 250. Set this to, what do we do for the new game button? Yeah, 0. Okay, so this will be 0. And then this is 214, I believe was the same. Yep. So that's that. So this will be, let's say, your best score. And in this, we'll add 2 labels. So we'll add one piece of text and another, and another piece of text. And here on our thing, we can add a vertical layout group, which will just make it quick so we can align those. For this one here is just a quick label that says best, and it's going to be really small, so it's kind of hard to see up there. We're going to center align it. We're going to uppercase it. I'm going to change the color on it. Okay. Also, I want to make sure that on our vertical layout group, it's controlling the width of everything. And then also I want to line these in the middle. Okay, I also want to change the font to be bold. For the actual value of the score here, this will be 0 to start. Also, I need to set the heights of these. So the height of our little label will be 13. The height of this will be 25. The font size will be 25. It'll be center aligned. The font will be bold. I'm going to change the alignment to middle line. Yeah, same for this one. Okay, I think that's good. Maybe the pivot point will change to 1. Actually, it doesn't matter if we're using layout group, but yeah, I don't think it matters actually. Okay, is that it? I think that's it. It doesn't quite look the way I want though. So let's see here. Oh yeah, we don't want to force expand the heights. There we go. So that looks better. And then maybe we just give it a little bit of spacing, like 2 spacing. So that looks good. So the little box with the label to indicate what this value is, and then the value itself will get changed. Yeah, I don't need to set the pivot point. It doesn't matter since it's just being controlled by the vertical layout group. Now I'm going to duplicate this, and I'm going to change this one to be score. So this is like your current score and then your best score. I'm going to shift this over. So let's subtract 112 and then subtract another 12. Yeah, that looks good. And this one will change the label to just be score. And we're good there. Cool. So we have 2 boxes for your current score and your best score, and then the new game button. All right. In our game manager scripts, let's establish some references to those score text. So let's import using TM Pro, public text mesh pro UGUI score text, and text mesh pro UGUI best, or maybe I'll just call this high score text. And from here, let's write some functions to actually set your score. So for one, let's have a function to, we can make this a private function to set your score. So be an integer. Oh, also we need to actually have a variable to save what your current score is. So here we'll assign that. Then we'll update our score text to be that new text. Now we also want to save your high score. So anytime your score updates, we want to save your high score if it is higher. So let's have a function to save high score. And we're going to save your high score in player prefs, which is a way to save essentially data across sessions. So even if you load up the game, you can close the game and load it back up, it'll still save this value. So first we need to load what the current high score is to check if this new score is actually better. So let's load our current high score. Let's create a function for that as well. Load high score. This is just going to return player prefs.getInt. And then we'll use a key to indicate what this is. I'll just call it high score. We can also provide a default value. So if a high score has never been saved, this will be a value that gets returned as a result, which will be 0. So now we can load your current high score is here. And then if your current score is greater than the existing high score, well, now we can save this as your new high score. So this will get saved as your new high score. And this will get potentially saved anytime your score updates. Cool, so this looks good. Now finally, we just need to actually increase the user score anytime they merge tiles together. So for this, we'll have a function called increase score. And let's say by however many points. And so here we'll say set score to be score plus points. And that's it. So then finally in our board script, whenever you merge some tiles together, we can increase the user score. So here in our merge function, we can say game manager dot increase score to be whatever this new number is. So once the number has been figured out, that's how much your score increases by. All right, and then finally, when you start a new game, we need to reset score. So we'll set score to 0. And we'll also set our high score text. So anytime you start a new game, it's going to load that high score and store that in the high score text. And I think that's it. I think that is the last line of code for our game. Let's test this all out. Okay, I got a null reference exception because I forgot to assign our new references here. So for the score text, let's go to this. Make sure you're using the value label here. And then same thing for best here, or high score, whatever you want to call it. Okay, so yeah, I already have a score saved apparently. So it already loaded that from me making the game previously. And now as I play, my score updates. So for example, if I merge in these 4s, I should increase this by 8 and this should become 64. Perfect. Awesome. And if I click new game, it should reset, and it does. Awesome. So there we go. So that is a fully working game of 2048. Feel free, obviously, to customize things. You can completely go and change the colors of everything. You can change what the states, the tile states themselves look like. You can change the way the UI is designed. For my project that's saved on GitHub, I actually designed the UI slightly differently. There's just a little bit more to it. You can see real quick if I pull this up. This is what the project looks like on GitHub. So it's organized a little bit differently, but more or less it's the same. Just kind of has the actual title and description. You know, so feel free to customize this and make it look unique to your own liking. But that is it. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel for more videos just like this one, and leave a comment recommending what you would like to see next. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including early access to future tutorials and the Unity assets that I develop. Link in the description of the video. Thank you for watching. See you in the next one.